This lesson is going to be about finding the area of polygons with the help of Right Triangle Trig. Right Triangle Trig should lead us into remembering this mnemonic, which was the sine of some angle theta equals the opposite leg over the hypotenuse. The cosine of some angle theta equals the adjacent leg over the hypotenuse. And the tangent of some angle theta equals the opposite leg over the adjacent leg. So we're going to use this in order to help me find some missing pieces to find the area of this triangle. So this triangle, the area equation is 1/2 base times height. If I draw in the height right here, remember the height and base are perpendicular to each other. This we're going to refer to as the height. I see that I have a base of 11 and I'm just missing the height. So right now I have my equation. I also have a right triangle that will help me figure out the missing pieces that I need for that equation. So if I want to find the height of the triangle and I have this angle, I'm going to set up this trig equation. The sine of the angle is going to equal the opposite leg over the hypotenuse. This is the trig equation that I'm going to use to find the height of the triangle. I can multiply the 10 over, so I get 10 times the sine of 40 is going to equal the height. Plug that in my calculator, I will get the height is going to equal 6.428. So right now I have everything. I have 1/2, the base is going to be 11, and the height is going to be 6.428. Multiply all that out, and that will give me 35.354 units squared. And that is going to be the area of the entire triangle, in which I could find by getting the height from trig multiplied by the base, divide by 2, and that gives me the area. So I got to remember a few things. One, I got to know the area equation. Two, I got to find all missing parts of the equation. And 3, calculate the area. This is an example of finding the area of a regular pentagon with side length of 14. In previous lessons, we talked about what kind of triangles make up this pentagon. And I got to remember that there are 5 congruent isosceles triangles that make up this pentagon. So in order to figure out some of the missing pieces that we may need for the area of this triangle, I know that all of these angles up here are going to add to 360. So I have 5 angles that add to 360. That means each of these angles are going to be 72. I also know that this side is 14. So what I would like to do is I would like to find the height of this triangle. So let's just focus on this triangle over here. So the height of the triangle is what I am missing. I know that the side is 14, which is going to make this side right here 7. And then I just got to figure out this angle down here. Well, remember, it's isosceles, and this angle up here was 72 degrees. So if it's isosceles, these base angles are congruent, so each of these are going to be 54. Now I have enough information to set up a trig equation in order to find my height. So if I am dealing with this angle, the height, and 7, my trig equation is going to be the tangent of 54 is going to be the height over 7, multiply the 7 over, times the tangent of 54, and that will give me a height of 9.635. So now I have enough information to find the area of this triangle. So the area of this triangle, which is the same as this triangle, my equation is area equals 1/2 base times height. The base we said was 14. The height we calculated at 9.635 times 1/2. That is going to give me the area of one triangle. So the area of one triangle is 67.445. Now a lot of kids like to stop here, but you're better than that because I want to find the area of this entire pentagon, which is 5 triangles. So it is 5 times 67.445, which is going to be 337.225 units squared. So remember, I need to find the area of one of these isosceles triangles, and there are 5 triangles throughout the entire pentagon. So it's just using trig in order to find my missing pieces in order to get the final area.